Hello everybody, welcome to aga-cad. My name is Jokubas Vaishvila. I am project manager and application engineer from aga-cad and tools for Revit. Firstly, what I want to ask you is to raise your hands if you can hear me and if you can see my screen. So you can do that on the right side of your monitor on GoToWebinar dialog block. Okay, I see some of you could hear me, and yeah, many of you could hear me. So thank you for attending this webinar. Today's webinar will be based on ventilation systems, basically on MEP parts creation and use in ventilation system design. Shortly I will introduce you who we are. So we are a pioneer in the development of Autodesk Revit add-ons, and we are golden partners of Autodesk. Also, we are authorized training center and authorized developers. This is our team. Our team consists of 20 employees and with engineering and management education and practical Revit experience. We have 4 departments. It's programming, project management, training, consulting, and sales. We have been providing design software since 1991. This is a bucket of our solutions and tools, and mainly we will speak today about the MEP Engineering Pro package and the Smart Diffuser solution. Also, we have the smart sprinklers for sprinkler systems, our heating for heating system design. Also, we have the smart hangers for hanging and supporting line-based MEP elements. Also, we have the BIM Tree Manager, Sustainable Design Pro, Revit Content Management Solutions. Also, we have the package for wood framing. Also, we have the very new product that goes for smart assemblies. So you can try it and by yourself if it's needed for you. Also, we have the tools for Revit, so it's little tools that can help you while working with your project. That's like quick dimensions, smart sheets, and many more things. And today I will show you a little bit of our created room area and space manager. Also, we have the Cut Opening Pro. That this solution goes for cutting the openings around the MEP elements in a project. So I just want to go to my Revit and show you what's happening there and what we have there. So this is the project that I have created with a ventilation system inside of it, and I left one space here to work with it, and we will distribute the smart elements here. We will find the optimal size and optimal diffuser size according the airflows inside the space. Today we will use 2 different tools. One is solution for smart diffusers that goes not only for diffusers but for whole ventilation system design. Also, we have the RAS manager that goes for calculation of supply airflow and exhaust airflows. In the very beginning, I will start from creation of our smart element. I have loaded some different elements into my project, some different air terminals. I will drag and drop them into the project, for example here, and this is very simple geometry of the diffuser. That we will add some information inside of it using the manufacturer's given graphs. So we have only the geometry of our air terminal, and it don't have any flow or more something like a pressure drop or velocities here. And we will add some information using smart diffuser solution. What we will do, we will add to family some different configurations. Firstly, we have to identify according what parameters we have our chart, and we will make some parameters here. So I will put on this family the pressure drop chart, and that has the relation. It's like a function of airflow and type dimension. So we have many of these relations here, but we have to use this one for such charts. If it's needed, you can create more charts, more than one, more than two. Even you can make as many as you want by clicking the new ones and making the new ones here, and making them by some relations, and all these configurations will go by some kind of priority. For example, if we will get the work point on the first chart, that point will go through all our charts. For example, if we will get at the first chart, we will get some information about pressure drop and the flow. From that, we can get the flow and many more things that are given in such a diagrams like I showed before. So today I will use only one of the configurations that will go only for the pressure drop. Okay. Firstly, what you have to do is to check your units. This solution works with many kind of units, but you have to identify only the units that are in your diagram. So in my case, I have the pressure drop in pascals and the airflow in liters per second or in cubic meters per hour on that chart. And that is all. We can go to our PDF that goes from the manufacturer, and easily we can just take a snapshot and get back to our Revit, to our smart diffuser solution, and paste our chart images into our dialog block. Also, we can resize it and use it for scanning. And now I will I will scan this image, and I will change this graphical view into numerical thing that will work with our family, with air diffuser family. Firstly, what you have to do is to identify the dimensions of our chart. So the first thing what you have to do is to pick the left bottom corner here to identify the very first point on a chart, and you have to pick the right top corner to identify the very end of this image, of this chart. Now we have the dimensions of our chart, and we have to identify the airflows, at what airflow our chart starts and ends. So here we have 30 liters per second that goes from here, and we have 1,200 liters per second in the end of our chart. Also, we have to identify the vertical axis. We have 7 pascals here, and we have 150 pascals here. And our chart was scanned. Now we have to identify our types of our created family. You have to create your different types for your family, and you have to identify each of them. I will use the pick line start point and pick line end point to identify the inclination of this line. If we have 2 points, we can get the line. It's like if we connect 2 points, we can get the line. I pick the first point somewhere on the first line that goes for the 100 diffuser, and I pick the endpoint somewhere here, and automatically it will know that the inclination will go in such a way because we have 2 points that are connected. As you see, all the types are inclined in the same manner, so we can just multiple the first line by picking the points on each of family type. I will pick here, I will pick here, and anytime you can see where you have to pick which line you have to pick. Now I have to pick the 200s. Now I have to pick 250, 315, and 400. And that is all. Our chart was successfully our chart information was successfully collected, and now we can work with that family. Also, we can make some additional attributes. It doesn't matter what kind of attributes you will use here, because you can use these charts and this information not only for diffusers, but you can use this information for your silencers, for ventilation units, and many more things. You can use this thing. So I will use the sound level that is very interesting in this part. I will use 35 decibels here, and I have to pick points on that line that goes for 35 decibels. And this line will be like a maximum line, according which we will find the best suitable ear terminal in a space. Also, I have to pick this, and I will add. As you see, we have the red line that identifies the maximum sound level. If we will use the same diffuser in 2 different premises, we can make 2 different sound levels. For example, if we have in one premise maximum sound level like 35 decibels, in the second we have 40, and it doesn't matter. We can pick points on our chart and collect the information again, add that information to our chart, and we will be able to use these maximums for our finding the solution. We have created one more functionality, and that goes for different for parts that have different images. For example, if you have the diffuser ear terminal with a plenum box, each type of the diffuser will have different charts. It doesn't matter for this solution. You can use separate images for each type. You have to firstly you have to create your family types, and then you have to place your charts on this dialog block very easily, as I showed for you here. And that is all about creation of the family information, and we have created the information that goes into the calculation inside the Revit. And I will show you very fastly that what we get here. As you see, we can find some information. Here we have 500. For example, if I want 300s, it says that the value is out of the chart zone. That I could know that I have to use the different family type. So I have to use the different family type. If you will have many configurations, as I said, you can place many of charts of different charts on this one family. You will be able to choose these configurations here and to find the same point on the other chart. And I will delete that from the project. Yes, okay. Also, what I want to show you, it doesn't matter what kind of elements you will use here. For example, I have here silencer, and I can check. Yes, here we have the chart for the silencer. If I will add some parameters to my silencer, for example, if I will connect that silencer to my system, I will get, for example, 2000 of cubic meters per hour going through this silencer, and I can find that it will get, according to this, we will get such a pressure drop inside of this silencer. And for example, if it's needed, we can use the different ones. Okay, fire damper. Let's check what is inside the fire damper. Yes, we have such a charts placed on our fire dampers, and we could use them. Then we will place them on our system, and it automatically will find the pressure drop inside that element. The next thing what I want to show you is the RAS manager, room area and space manager. Here we can upload our standards from our country and use them for the temperature. For many things could be used from there. That is written in TXT files, and we have the HVAC zone that identifies not only the temperature but also the airflows that is required for that premises, and many more things. So it's really easy to create your own rooms and your own spaces and use them here. And I will show you fastly how it looks like. Firstly, what you have to do is to place some rooms inside the project. I will use Netherlands like an example. The Netherlands has such a building types and such a room names that has such HVAC IDs. According to these HVAC IDs, it will get some information about that space. And for example, I want to place such room inside my project, and as you see, room was found, and we will replace it. We have replaced our room, and we can make that not manually. We can make all the things automatically, place rooms from current project, and all the rooms will be done by your computer. After the placement of room, I could in the same place I could place the space that will have some information inside of it. And we have selected one room, and we found that we can place one space here. Yes, and as you can see, no. Yes. Now, okay. As you can see, we have a space and the room in the same premise. What we can do now is to calculate the specific supply airflow or return airflow for that specific space that has some information inside of it. Oh, this space is placed on the first floor, and yes, here it is. For example, if we have the supply air per person, we can calculate the supply air by area, by air change per hour, and by person, as I said before. For example, I will calculate the specific supply air flow by area, and here I should find some number here. Okay, I remember that was on the first floor, and that it is the same space. We have 1628 cubic meters here. For example, if I want to calculate supply air flow by air changes per hour, I could identify the air change inside that space and calculate that information according my needed configurations. That is really easy and really fast. It goes through all the spaces now. If you will identify for all the spaces all the characters, you can find that information for all of these spaces at one moment. And as you see, we have calculated 7,209 cubic meters for this current space. In the same manner, you can identify the return airflow. Let's get back to our smart diffuser solution. We will distribute our elements in this space using some different rules, using our created dialog block. Here you can identify the elevation of your placement of elevation of element. Also, you can identify the flow, the calculation elevation. Also, we can identify the distances in between elements. If we calculate, it automatically calculates the number of elements on X and Y directions here. Yes, also we can make the offset, current offset, for example, I want to make it by 6 meters here, and it goes by X direction here by 6 meters. And if I want to use the 6 meters in the other direction, it will recalculate, and it will place all the diffusers in this area. If it's needed, you can change the arrows here, the directions of X and Y, by picking a new wall that goes for X direction, for example. Also, there is a possibility to identify the maximum distance from wall. Minimum distance from wall. That identifies the minimal minimum distance from the center, from the element to the wall face. And we can apply, as we see here. Also, we have created the mirror functionality that makes that mirrors the view, that mirrors the axis and the element placement on that axis. And that was only the position mark. On that this position mark, it's only the connection in between the space and the diffuser. So if you will move the space boundaries, all the elements will move together, and all the distribution will be recalculated at that moment. You can turn on or turn off that functionality. And I will place our created diffusers on these symbols, and all the diffusers was distributed according our very first distribution with position symbols. At any time you can manage that thing. Now, after the calculation of airflows inside the space, we can find the optimal diffuser type for this space. Let's look how it looks like. As you see here, we have the same maximum sound level that we have added before. We have two of them. Here we have the green line that identifies our used diffusers in the space. If you see that it is possible to find the other diffuser, we can press to find type for that diffuser. And as you see, it changes the position on that chart, and also it changes the airflows and the pressure drop inside the element. If we decrease, and if we see that it intersects the red line, we also can find the type, and the solution will automatically find the best suitable type for such a situation. Again, if we have less and less diffusers in the space, now for example like this, and for example it's different space, and we have 40 decibels maximum sound level, we also could use the same functionality for this space. And after clicking OK, all the information will be written into our families. As you see, we have the flow for that family. Also, we have the velocities and the pressure drops. This is very easy and very useful thing for creating your own elements in the Revit. You can use smart diffuser solution not only for diffusers, but as I said, for all the ventilation part that has logarithmic graphs like this. And that is the end of our presentation based on smart diffusers and the smart modeling there. Thank you very much, and if you have questions, you can write them inside the GoToWebinar dialog block. I have some questions. I have the question from Sergey. He asks me how could he correctly assign MEP spaces if he have the linked architectural model, and this model has different building phases. Um, so uh, you have the different HVAC HVAC IDs, and you could use them. I think so. I will check everything, and I will write you straightly an email, and we will we will be able to speak about this situation wider. If somebody have more questions, please ask. So, in the beginning, in the ending of this presentation, I want to say that I will send you an emails with the trial versions of these solutions and tools that I showed you on this presentation, and if you will have some questions, you will be able to ask me straightly, and I wish you to try these solutions, and I wish you to work faster, better, and stronger. Thank you for your attention, and have a nice day. Goodbye.